Okay, today I will show how to derive Schrodinger equation in one dimension. First, we start with these three equations. E equal to h bar omega, p equal to h bar k, and this is the wave function. H bar equal to Planck constant divided by 2 pi, and k is the wave number. So to solve the Schrodinger equation, we start with we gonna diff wave function compare with x, as you can see here, and then you're gonna obtain this differentiate equal to I k phi, and then we're gonna diff again, and then you're gonna obtain this equation here. And then from the momentum here equal to h bar k, you can obtain a k equal to p divided by h bar, and then we can substitute k into this equation. So we're gonna obtain this equation here, and then we rearrange this equation in terms of p power 2 phi, and then it's going to equal to here. So I will call this equation 1. So next, as we know that the total energy is equal to kinetic energy plus potential energy here, or we can write it in this term here. Kinetic energy is equal to 1/2 mv square, and for the potential energy, normally we write in U or V, but in this case I'm gonna write in U here. And then from the kinetic energy here, we can write in terms of the momentum, as you can see here. So this is the kinetic energy, this is the potential energy. And then from here, this equation here, if we multiply this equation by psi, so you can obtain here, so E psi p power 2 psi divided by 2m plus u psi, as you can see here. And then from equation 1 and 2, you can see the common term p power 2 psi here. So we're gonna replace this term into this term. Finally, you're gonna obtain this equation here, equation 3. And normally this equation 3 here we call time independent Schrodinger equation in one dimension. So next, if we want to solve time dependent Schrodinger equation, we start with wave function again, but in this case we're gonna diff wave function here compare with time, and then when we diff it, we're gonna obtain minus I omega psi, as you can see here. And as we know that the energy equal to h bar omega, and then if we multiply this by the wave function in both sides, so you're gonna obtain here. And then next, we just rearrange this equation by multiply or by the minus I over h bar in both sides here. So you're gonna obtain minus I omega psi here, and you can see that this term and this term is the same one, which is equal to diff wave function compared with time, as you can see here. And then we rearrange this equation again by moving minus I to this side, h bar to this side here. So finally you're gonna obtain this one. And for this, if we can move I to above, as you can see here, and from equation 3 here, you can see this term E side, and this is E side, right? So we're gonna replace this term into this equation, and finally you're gonna obtain this equation. And this equation we call time-dependent Schrodinger equation in one dimension. So this is the result that we try. So thank you very much